Hello everyone. In this video, we are going to discuss about an important topic for CSIR and GATE exam. So the topic is isolable analog. Analog means if you have two things and they behave similarly, then we used to say that as a analog compound to each other. So they are similar but not identical. So this is a qualitative approach. So isolable analog is a strategy used in organometallic chemistry to relate the structure of organic and inorganic molecular fragments. So in order to predict bonding properties of organometallic compounds. This isolable analog was developed in the year of 1981 by Professor Roald Hoffmann. So you can see it is newly developed method and it will be very much useful to synthesize new organometallic compounds. For example, if you are going to synthesize an organometallic compound and you need to substitute some new group in that, then this isolable analog will be useful. So let's see what is this isolable analog or fragments. So these fragments have similar properties of their frontier molecular orbital, that is F and O. So that relates to their HOMO and LUMO, that is highly occupied molecular orbital, and lower unoccupied molecular orbital of that compound. If you have two fragments that may be main group compounds or transition metal compounds or combination of that, let's take F1 and F2 or the two compounds or two fragments. Then they should have similar shape and they should have similar symmetry, similar number of energy and same number of electron. Then we used to say those two fragments, that is F1 and F2, are isolable to each other. So let's take this example. Let's take the CH3 and D7 metal complex, that is manganese carbonyl compound, MnCO5. Then we'll calculate the electron count in this CH3. If you count this electron, carbon will have 4 valence electron and each hydrogen will have 1. So totally you have 3 hydrogen. So 4 plus 3, 7 electron for this CH3. And if you go for this D7 metal complex, we'll take this example MnCO5. Then manganese is a D7, so it donates 7 electron. So each carbonyl will donate 2. So 2 into 5, 10. 10 plus 7, 17 electron. So this is an organic compound and this is a organometallic compound. So this is a main group compound. It obeys octet rule and have 7 electron, whereas this is organometallic compounds obeys 18 electron rule, which have 17 electron. So 17 electron compounds will be isolable to this 7 electron system. Similarly, 18 electron compound will be isolable to the 8 electron system, and if you go 16 electron compounds will be isolable to the 6 electron compounds. So this will be proved if you see the properties of this CH3 and MnCO5, and if you see the properties, both these compounds will be exist as a dimer and they have they will reduce to anion and you will get this manganese CO5 minus, as well as for CH3 in case of Grignard reagent you will have this CH3 minus, no, and they are a conjugate base of an acid. So these two compounds have a isolable analog to each other. So they are not identical, but they are similar. So this is the concept of isolable analog, and it will be very much useful in the organometallic chemistry when you synthesize new organometallic compounds. Thank you.